Hello everyone, I'm Xiao Gang. Okay, in the previous lesson, we spent a full half hour demonstrating this. Now we need to add a bit more and refine it a bit. Because this thing, it seems to be messed up. Don't worry about it. Let me handle this side a bit. Okay, I clicked around a bit. I probably accidentally changed the format of its main annotation. File structure, not a big concern. In the previous lesson, I explained this binding method in detail. There are actually many other binding methods, but to avoid adding too much burden on everyone, we'll just pick one to demonstrate, and then we'll just bind it to itself. We won't write another actor and then bind it, just demonstrating for you. You can have different objects interact with each other. Now we can just bind it right here on itself. Let's look at this delegate. Let's look at the first delegate. How else can it be bound? In begin play, we'll go through them one by one. Ideally, we'll just bind this instance directly. We better declare another one. Declare a very simple one. Let's call it single delegate. Looking at this name, it shouldn't conflict with our hidden details, right? It shouldn't be that unlucky. But actually, there are hidden details. The hidden details actually help you declare some delegates. This is very normal. So let's follow the order. Let's look at the first one. The first one is called lambda. It is a function bound to a lambda. So it's actually like this. Its advantage is you don't need to write header files or anything like that. Whoever uses it binds it. Then this can capture some context. This lambda is basic C++ class skill. Then because the function signature here must be consistent with it, because the function signature here does not have this parameter, right? And it also has no return value. So if we still demonstrate it to you, if we have this here, let's also call it simple delegate location. This one has a return value and parameters, but this delegate actually needs to be bound like this. We'll just write it out for you. You'll understand at a glance. So the correct way to write this delegate meme should be like this. Pay attention to the function signature. The return here is just a vector. Okay, and the parameter it takes is unfake. You can pass other structs. That's fine too. Now, you know that starting with a capital F most likely means a delegate or a struct. Okay, so this is what a normal binding looks like. Okay, so the operation they need to perform is actually very simple. We can just take this part and paste it over, directly over to the first one. We might buckle another one of these. Just buckle it, and that's fine. Okay, well, it's simple. There's a problem here. Why is that? Because they need to capture something. We can capture the res. Yes, that way we avoid issues. And put the location here. Okay, there's no str here, right? We can provide an inst. That way there's no problem. Okay, note this res pointer. Using it here should be fine. But there will actually be a problem here. It is possible that when this agent executes, this actor is destroyed. This part is debatable. This kind of writing style is debatable. Writing it this way is not good. So let's not capture it this way. Let's give it a like this. Because I think if this writing style is left to you, you will make mistakes in the future. Because I have made such a mistake before. Okay, then this place will print a vector of 0. Here, we'll just type a random character. Here, we can type out this function signature. Simul delegate execute. I don't know if there are any comments in the place. Forget it. Here, we'll write one. Let me show you this, what the function name in this place looks like when typed out. Okay, good. Now we have two delegates bound during begin play. The bindings are two lambdas. For testing, we'll do it right here. We'll write it here and call myself lambda. Okay, then we'll implement it. So we can do this here. We just take these two agent roots and just let them execute directly. We don't need to receive anything else, like return values, that kind of thing, because I've already shown you how to receive return values. Okay, so this way we can execute. Let's take a look. It seems we need to pass a parameter here, right? We'll give it a string. We'll just give it a txt. This time this is lambda. Okay, so let's take a look at what the problem is here. Take a look. This seems to have a problem. Let's see how we wrote it before. When it was executed before, it gave take a look. Q's. Or can we do it like this? Is it okay? Hey, like this it works. Yes. Okay. Okay. Alright, let's execute it like this. Let's take a look at this single wave binding of lambda. What kind of effect it produces when executed? Compilation error. Let's check what the cause is. This place is normal. It's because we didn't return this value. We just printed it out. Let's run it again. Okay, let's go directly to our observation chart. For this test, it seems we don't have enough keys available. So let's disconnect these keys. I will disconnect them. We'll keep only one key. 1. Okay, similarly, let's call this thing. Then here we input xg. So the test is to call myself lambda. Let's test it again. What kind of effect does this lambda have? Then pay attention to the log. We can take a look. You will notice execute, right? Both of these lambdas executed, and at the same time, you will notice this F3. After it prints out, it looks like this. It is in our single delegate actor begin play. Then there is a lambda. That is the position of this function signature. And the second one is, this is lambda. It provides a location. You see, there is no such problem at all. Take a look and match it out. So it corresponds to this position. This place is the location of its function. That's roughly how lambda is used. Okay, and this is the way lambda is bound. We will use it many times later. Here is just a simple demonstration for everyone. Then, if we continue writing below, continue writing further down. Let's add another one. It's better to change the name for this one. If it's not easy to change the name, we can rename it like this. Let's give it a name called lambda. Yeah. Then give it a lambda here as well. This way, when you look at it later, it will be easier to read. Take a look at the code, because this code will definitely be shared with everyone, so that when everyone reviews it later, they won't need to watch the video again. Just look at how the code is written, and it's better if you follow along and write it yourself once. That way the effect is the most profound. Sometimes, most of the time, I just look it up online. What did you cut upward? Yeah, the one that goes upward to mess with. Yes, I generally don't remember much. I usually just search for it online. This one is bound to native C++. Let's declare another one here. Let's call it Shanke agent cans meet. We bind it here. Obviously, we need a bound meet here. We can see how bound meet is bound. Actually, it's very simple. We directly bind the bound meet. Let's do a global search. Then we just copy it and we look. You'll notice the first parameter passed is z. It's a struct, right? Then z, and then this function is passed. So we might need to write a struct here because it should be writing it's right. Okay, let's go write a struct. For this struct, we'll define it up to this point. Plus fsg 2 the single row struct. Then for this struct, we need to write a method. For this method, we'll call it row location. Yes, actually that's it, it's fine. We can implement it. For this implementation, let's keep it simple. We'll put it here to avoid contaminating our original files. As for this implementation, we'd better add a log. Also, let's add a log here. Then we'll give it a random name. Just use a print to say that this place has been executed. Okay, now that we have it, actually for the binding here, if we need a ship, we might need to write a struct. We'd better give this struct a pointer. Then we give it row struct. Paste it, then let's take it for a spin. This is one of the rare times we take this for a spin. We usually don't take it for a spin if we want to place it here to demonstrate to everyone. Then pass this pointer in. Then here, we capture this method. It is this method, right? We set this permission to public. Then we capture it here. Check, no problem. Then we execute it. No problem, actually, like this. We can also do this inter-sensor health here. Then we'll still give you inter-sensor. Let's give it a composite. In sensor, k node money equals sensor. Okay, good. We pass this in here. Pass it in when setting it. Good. At this point, we need to here give it an in the sensor and then inc node money. This is a composite concept. Let's briefly review this again because it is really important. The concept of this load. Then we will talk about when it cannot be combined, how we can do some, that is, sometimes if you have to do it in blueprints, then you cannot combine it, and we have no way to handle this situation. Of course, we have ways to handle this situation. We can use this ID-based approach to handle it. Okay, let us demonstrate it for you. We will demonstrate in this lesson the native definition method of this lambda and this row. Okay, then let us... Did we forget something again? Right, we forgot again. Sorry, this writing. We still need to write a test here. This test, let's just call myself row. Right, forgot this again. Forgot it again. Right, this call timing is actually quite critical. So obviously here, we no longer need to pass parameters. We'll demonstrate it in the simplest way. If we were to do a full demonstration for everyone, this code might become too bloated. Because you can see, we still have mute later. Also dynamic mute, also dynamic single, yes. So everyone try to draw inferences from one example, right? Then you only need to know how to write one type. For the others, you know, and when you don't know how to write, just by do it, okay? Then here we use this xg and call ourselves row. Okay, let's take a look here. Why did we leave it on the heap? I'm just afraid it's absorbed enough. So here I deliberately let it slide onto the pile. Hey, you'll find that this method function has been successfully executed, and actually if you write it like this, there might be a problem. Yes. Then I'll tell you what kind of problem writing it this way can cause. But if you declare it like this, for example, if you declare it like this, right, declare it, and then you pass it in by taking its address. And sometimes it won't crash. Because you only use the function, it won't crash. But if you use this variable inside the function, for example, I defined a money here, or defined an attack power, then when you use this specific variable inside it, congratulations, you will cross over. This is the place mentioned in the document. It helps here. There will be such a problem. You can see, finding the native C++ pointer proxy. And here, first, it will not sort here. and it is unsafe. Unsafe. Yes, so be sure to remember this unsafe, so you must be very careful if you are binding this native thing. Okay, that's all for this lesson. Then we still need to look at a bit more because for this unicast there are still some knowledge points